Hey folks, here's our next page of the review. So this page talks about items like the exterior angle theorem, we see that in question 22, and the triangle sum theorem, which is also number 21. We also might see isosceles triangles on this page. So for 21, notice immediately the simple connection that the double slashed angle in each triangle has to be the same. So pretty straightforward, 85 degrees can be written here in this corner. Secondly, notice the single slashed ones here in that corner. Y matches with this angle. We'll have to figure this one out using our second triangle here since we have 2 out of 3 angles. The total has to be 180, of course, so if we add the two together that we have, we get 116 degrees. And 180 take away, trying to write some numbers here, 116, it looks like leaves us 64 degrees for this Y measure here in that corner of the triangle. For the other one, notice the X and the 31 are in the same position, so that's a piece of cake. That's just 31 degrees right there. If you double check all these measures, they should all add up to 180, of course. 22. From the marks on the picture, we have an isosceles triangle, and we have learned that angles across the way from those congruent sides are also congruent. So we could throw another X in the corner of this angle. And then from the exterior angle theorem, that says our exterior angle, which measures 158, is equal to the sum of the two angles far away. That saves us the time of working through linear pair measurement here and subtracting from 180 degrees. So if I add those two together, x plus x is of course 2x, and now I have a mini algebra problem to solve. Again, you do the opposite of what you see. So instead of timesing by 2, to solve this, we divide both sides by 2, and it looks like we get what will be 79 degrees for both angles in this isosceles triangle. 23 is a direct question and a direct restatement of your exterior angle theorem. The sum of these two angles is supposed to equal the exterior angle for that third angle in the triangle. So our equation becomes 142 equals x plus 66. Simple solution is to subtract 66 from both sides. And let's see, what'll that be? I think that gives us 76 for this particular problem. For the next one, in 24, notice in this triangle we have two interior angles and we have what can be considered an exterior angle. So once again, y equals 28 plus 53, and we very quickly come up with the measurement for angle y. If we can do some addition in our heads here, come on Grams, that's going to be 81. So this corner is 81 degrees. I can also put that up here where it belongs. And then of course in our second triangle here on this edge, we do have 2 out of 3 angles. So if we add together the two that we have, we end up getting 98 degrees, and we have to do 180 take away 98 to get the remaining measurement for x. I believe that'll give us 82 degrees. Very close answers there. 25, I see parallel markings, so just to highlight for myself, I'm going to trace over this one and this one. I'm going to go to black ink and notice that there is a transversal right here cutting through, which tells me that this angle and this angle have to be the same size. So let's come back to that in just a second. Notice here by vertical angles there is 100 degrees here in this corner. And by the markings on this triangle, if I can sort of make that red go away for a second here, notice those two angles here in the bottom corner are equal. So the sum of the triangle is 180, so the remaining total between those two is actually 80 degrees. So they must be 40 apiece. Now back to that original idea here. In red, I have marked, because of the parallels, two angles that are alternate interiors. So we know that if this bottom guy is 40, which we just figured out, then this top guy on the inside here must also be 40 degrees. And then by subtraction up here in this corner, we can get there's another 40 degrees up top. Apparently those two triangles are exactly equal to each other. By angle measures anyway, looks like the side lengths might be different. Now, as we start to get some angles we're really interested in, angle S, of course, must be 40 degrees, and that is by vertical angles with the red and the blue. And I see another set of parallel lines. Let me change to red. This line is parallel to this one. And I see another transversal cutting through this line here that was originally blue. Can now be seen to function as a transversal. Here is this 40-degree angle. The guy in this corner is the alternate interior angle, must be congruent. And that, if we've lost track of where it is, if I can pull back some of the writing here, that is what exactly the place we want an answer for angle R. So angle R here is 40 degrees. And then we can see we have angle R, we have angle S, and angle T up here in the corner is the third one in a triangle. R plus S, red plus blue, gives me 80. By subtraction, it looks like the measurement of angle T must be 100 degrees. So all of these triangles in this little picture looks like they're equal to each other by degree measurement anyway. Let's clear away some of our stuff here. You're welcome to stop this at any point or rewind if you want to see some of those again. So by these markings, all these triangles would be similar. Side lengths we know nothing about, so we can't make any conclusions there. On to 26. In 26, I notice that I have parallels once again. So I have some alternate interior angles going on, and it looks like up here in the corner 79 matches with this corner. So 79 must be the same as 50 plus B. Again, those are alternate interiors. We know because of parallel that they're congruent. So it looks like B is 29 degrees. Simple enough. Once we have B at 29, then we can shift our thinking to letter A. Notice here, this red one and the blue one above it are same side interiors. That means the measure of the red plus the measure of the blue, while they're not equal, we do know they add up to 180 degree total. So 180 will equal 79 degree angle plus the total of the A plus 23 angle. And if I combine like terms, 79 plus 23 is 102 plus A equals 180. And I think when I subtract that, I'll try to do that mentally, I think we get 78. I will keep 78 for that answer. And we'll pause here. Okay, let's slide our page up a little bit here and continue on. This is going to take a bit of work. I'll probably come back and solve this number 29 on a separate page. Alrighty, here we go. 27. Triangle sum is 180. I know that inside this triangle the total is 180. Three of them are all the same. So 180 divided by 3 is 60. That gives me this part of angle QPT. The second piece, notice this triangle is isosceles and right. And of the remaining 90 degrees in this inside second triangle, the two angles left have to make 90 degrees together, so each is 45. The third angle, there are no marks at all, but I see there's a 90 degree corner down here, and there is another angle which is congruent to one on the other side. So this must be 60. I know this bottom corner down here, where I made a little mess, is 90 degrees. Let me mark that as a red corner. The remaining amount of degrees then for this triangle must be 30 degrees. Now the angle they originally asked for all the way from P to Q to T here is going to be the sum of these three angles, and I believe that is 135 degrees. For the last one, notice all the angles inside the triangle have an X in them. That means our triangle will be made up of the total of each of those corners. 7x plus 30 plus 4x plus 100 minus x. As I'm looking for like terms, I can bring together my 30 and my 100. And I can bring together 7x and 4x and minus 1x. A little bit of a tricky situation there. The total is 10x, and of course I have to have my 180 over here. By subtraction with the 130, we see that we end up getting 50 over here. 50 equals 10x. Divide both sides by 10, we get x equals 5. There is one answer that we seek. And to find the measure of y, we can simply take that answer 5, plug it in here for the x, and realize we have a 35-degree angle. The rest of the measurement to make a 180-degree linear pair would be 180 take away that 35. That will leave us with a 145-degree obtuse angle. So the 145 goes up there, and the x equals 5 answer we can transfer into our answer blank.